Hey guys, it's Craig. I just wanted to do a quick video to accompany the blog post I've recently put up on provisioning Layer 3 MPLS VPNs asynchronously with Python code. If you look at the lab, we've got a not so typical provider MPLS backbone environment here. I know we should have a redundant P nodes and what have you. I'm no architect, so ignore the architectural faux pas in this. But what we're trying to achieve essentially is provisioning the configuration when we onboard a new customer automatically on these provider edge nodes. If we didn't do this asynchronously, and if we just did it with standard blocking code, we'd run into quite a few issues in terms of actual time to completion and scalability. We could provision all the configuration on provider edge 1 and then wait, and then configure it on provider edge 2, then wait, and then 3, and then wait. And then what happened if we scaled out the infrastructure, we added more provider edge nodes, we'd run into the same thing again. So what the asynchronous code aims to achieve is provisioning all the necessary elements in parallel across these provider edge nodes. So we create the VRF at the same time on all of these provider edge nodes. We create the IPv4 unicast address family in BGP, and then we create the southbound service side interface to the access network as well, all in parallel. So it should be a lot faster and help us scale. Like I say, if we add an additional provider edge node in here, that wouldn't necessarily impact the time that the code takes to run. So let's just do a quick high-level rundown of the code, and then we'll see it running. So if we just scroll up here to the top, we're just reading some configuration here from this config.ini file. This is where our new customer information lives. This could exist in a backend database or an API. This is just a quick proof of concept, so this will do for now. We are creating an MPLS provider edge class object here, and it has a number of methods. You'll note we're using the async keyword here to define a coroutine, and we are returning an awaitable object out of this coroutine. And this is the same sort of methodology for the rest of the script. If you look at this coroutine, this is create VRF, we've got update multi-protocol BGP, and where's the other one? Provision service side interface, and all follow the same logic. There's different nuances in the code. For the API, we're using REST-conf, and then here in the main function, we're just instantiating instances of this class. Just keep your credentials in environment variables. Don't follow me here. Yep, and we're creating a VRF task. We're bundling all these coroutines into this object here, and then we're just executing them concurrently. And we're doing the sleep function as well. I've noticed without it, sometimes I had issues with the synchronization of the netconf data store. I'm not sure if this is just my lab or whatever, but if I didn't sleep between these tasks, sometimes I'd run into dependency issues. So this was the way I found to get rid of that. And here we're just creating an event loop, and we're putting our main coroutine into this event loop, and we're just actioning those tasks in that. So let's look at the lab infrastructure first. To show IP VRF, we've got 3 customers, quote unquote, in our infrastructure currently, and we just want to provision a 4th. So we've got our customer information here in our config.ini file, and we'll just run the code now. You can see the VRF's been created, the address family has been created, and we're sleeping, and the service interface has been created as well. So yeah, that was relatively fast compared to something like requests, where typically we'd have to wait for this to function to finish, then we'd issue this one, then we'd issue this one. If you can see here, they actually execute in no particular order. We have provider edge 2 returned first, then provider edge 1 and provider edge 3. If we ran this again, if I was a betting man, I'd bet they'd probably come back in a different order as well. So yeah, that's the code's created. You can see it was relatively fast if you are familiar with something like requests. We can see here in the lab we get some messages about netconf. If we do show IP root vrf cust vrf Burger King, you can see that we're seeing prefixes already exchanged between provider edge nodes. That's the service interfaces. I'm just redistributing connected in that unicast address family, and the southbound service side interfaces have been redistributed, and yeah, so that's it. As always, all code's available on my GitHub. If you want to take a look at it on how you can write asynchronous code. I mean, there's some stuff in here that needs refactoring, but I just thought I'd get it out quickly while I've got a bit of time. One of the issues with running a blog and creating these blogs, you never know when you're going to have the time to upload stuff. So I appreciate some of the code might be ropey and might need refactoring and might not be to quote unquote PEP 8 style guidelines, but it is what it is. Check it out. Use it as a template to create your own synchronous code, and yeah, leave a comment. Cheers.